Networking, Part 2. In this nugget, we'll be addressing networking, and this will be Part 2. We're going to talk about, first of all, other cable media. That's because these are kinds of cable media that you're not going to see in common use, so I want to kind of clean up the miscellaneous stuff right at the beginning and get it out of the way, where we'll then move on to other kinds of cable media that we'll use more often. One of those will be coaxial, which is kind of a declining standard. We don't use it as much as we used to, but a faster standard and a better standard would certainly be fiber. Of course, in most local area networks, you're more likely to see twisted pair cabling, and we'll identify some characteristics of this cable as well. I remember years ago when I first got started in computing, I realized that I could actually use a network to transfer files from one computer to the next. And I kind of used a primitive system, but it was high-tech at that time. It was a network that we called SneakerNet. Yes, that's right. That meant that we would just copy the files to, at that time, what was the storage media of the day. That was a 3.5-inch floppy disk, and I would use my sneakers to walk it over to some other computer and transfer the files from the floppy to that other computer. Well, nowadays we have better methods than that, but I do want to point out something that's only slightly less primitive than the SneakerNet, and these come from the A+ exam objectives, and that's these kinds of cable media for network transfers or for network connectivity. And what I want to do here is to just get on my soapbox just for a moment and to point out that although these appear under Domain 5.0 for the exam objectives, where it talks about network fundamental principles, and it talks about these as being legitimate cabling methods for networking. Well, in my view, this kind of discredits the A+ exam objectives because anybody with any experience or know-how with networking would avoid these altogether. Is it possible to network with these different types of cables? Sure it is. Is it feasible? Not really in the real world. For example, why would you want to make a connection with an RS-232 cable, which, you might have serial ports that are only capable of 9600 bits per second? And of course, serial ports can be made faster than that, but overall, it's a very slow network connection. Now, this is somewhat feasible for certain server purposes. I mean, you can connect a terminal using an RS-232 connection, but we also use it mostly for diagnostic purposes. Maybe when a server won't boot up, we can take a laptop or some other network device and connect it to the back of that server through an RS-232 connection, and then we can get diagnostic data from it. In fact, current versions of Windows Server products support that for those types of purposes. But in an A+ world, I don't really see this happening very often, and I just don't think that that's very feasible. There's also 1394, also known as iLink or FireWire, and of course here now we have a fast connection, but once again, even though it's fast, why would I use 1394? I mean, if a computer is modern enough to have a FireWire port on it, then it's going to be modern enough also to have at least 100 megabit per second Ethernet port on it as well, so why would I even use this? And then finally, we could also go USB, which of course gives us speeds up to 480 megabits per second, so that seems fast as well, but once again, why would I do that? If it's modern enough to have USB ports, it's modern enough to accept Ethernet as well, and that would definitely be a better solution in most cases. Because Ethernet ports are designed, of course, for networking. USB is better designed for things like peripherals. Plus, in order to make USB a network connection, you have to get adapters to put onto the end of your USB cable to plug it into an RJ45 jack. There are adapters that do that, but why would I want to MacGyver something like that together to plug into an Ethernet jack somewhere, or an RJ45 jack? Why not just use a real network cable in the first place? So we'll just discard these. Just know that these are listed on the A+ exam objectives. But in my professional opinion, I find them not very feasible. Now here we also have something that is starting to be kind of a declining standard. We rarely see coax cable connections anymore, but it's listed one time just briefly on the A+ exam objectives, so I want to make sure that you have more than enough information, really. And everything I'm listing here is more than you need. And I also have a Word document that will accompany this particular video set in order to cover some of these as well. But let's just briefly address what some of these things are. First of all, when it comes to that first one, which is RG6, this is really used for satellite links, so we don't really use this in an A+ context very much. This RG6 type of cable is the same, visually it looks a lot like the kind of cable you plug into the back of your TV from your normal cable provider, but it's probably going to be bigger because it has lots of shielding in it. In fact, it has double the shielding as other kinds of coax cable, and we don't call this coaxial usually, we just call it coax. And then RG8 is what we use for something called thick-net Ethernet. And like the name sounds, it's a thicker kind of cable. Well, with this, we have copper braiding in it that gives it very good shielding, and it's going to be a pretty good network cable. that is probably going to be more commonly used for backbone connections than it would be for just drop cables to individual PCs. So to briefly cover those last two kinds of cable, here we have an RG6 cable, and notice that it has the normal foil that you'll see on any kind of coax cable and braiding, this metal braiding here, but it doubles that over here at this end, so we get quite a lot of shielding out of this. And then here we have an RG8 cable, which has the copper shielding right here, the copper braiding, which does a very good job. And by the way, the braiding and the shielding there is useful for shutting out electromagnetic interference and other kinds of electrical interference from other nearby magnetic or electrical devices. And then this RG58 is more likely to be used for a drop connection to an individual PC. Like the name would imply, with this kind of cable, it's called thin net Ethernet, so it is a thinner cable than the RG8. And it looks very similar to your television kinds of cable. The difference there is going to be the resistance is different. The electrical resistance in ohms is slightly different than the cable TV kind of cable that you would use, and that would be RG59, and I just list it here for comparison purposes. Now, to connect these kinds of cables to network cards or other kinds of network devices, we'll commonly use a British Naval Connector or a BNC. I don't know why they call it British Naval Connector, but that's just what it is. And when we take a look at this, here would be an example of a 10-base-2 cable with a BNC connector on the end of it, and these you push on to something like a network adapter, and then you twist it. You'll also see this kind of cable that still connects commonly to things like Cisco routers or any other kind of a router or networking equipment. Again, very often this will be used for backbone media. Less likely to be used in a connection would be an AUI or an attachment unit interface, and I'm going to kind of quickly address the rest of these because it's not prevalent on the A+ exam objectives. But here's what we would see there. First of all, as long as it's noted here, this is where the BNC connector would connect to the network card. You would simply slip it on there, and then you would twist it on, and it has kind of a locking mechanism. And then the other part that I'm discussing here is the AUI interface, and it looks kind of like a gaming port. It has several pins here that you can plug it in with, and it uses 15 pins in that connector. And you wouldn't connect both of these at once. It just depends on what the media requirement would be. If you happen to have a BNC connector, you'd connect here. If you needed to use an AUI, you would connect here, of course. And then when it comes to those AUIs, let me actually show you another picture here as well. We would have this AUI transceiver. So we'd plug in our 15-pin connector on our network card on one side. The other end of the cable would then connect here, and then we would have a BNC connector which would complete the connection to the rest of the network. And you can see here, by the way, it might be a good time to point this out, that you have a LED that will light up here, and it gives a different legend for the different things that are going on. It tells whether or not it has a heartbeat detected. That means that it can detect network activity. There's certain things that confirm that the network activity is going on, and other things that identify whether or not you're having a problem or whether the power is off or so forth. This will apply both to coax connections like we're looking at here, as well as to Ethernet connections, and you just have to look at the legend for whatever the lights mean on that particular device. And then you would also use a T connector very often to make your connection to your network card. So for example, here, I'm looking at the back of a network card. Here I've got my British Naval connector, which makes the connection. But this T, what that's for is, here it might be coming from some other upstream device. And on the other side of this, I might have another device further downstream that we also have a connection to. If there is no other connection to any other downstream device, then I put a terminator on the end of this, and that's what we're looking at here. And that terminator will prevent signals from bouncing back and forth. It dampens the signal at the end, so we don't have kind of a network echo going on, which would make communication impossible. So anyway, that's what the terminator here is for, so I'm a little out of order, but let's also talk about a vampire tap. This sounds just exactly like what it is. It uses kind of a long tooth here to poke into the actual core of a coax cable. And so you will see what would happen here is we might put our backbone through here, and this is just a side view of this same device. These are both the same device, just different perspectives. And we'd put our coax cable right in here, and then you tighten down this clamp on top of it, and then there's a tooth right there that pierces into the coax cable. So this backbone cable goes along here, and then I have my individual computers that are connected, for example, by using an AUI connector here. So we'd plug in one end here, the other end would go into the back of a computer, and voila, we've made our connection. But again, we're seeing coax cable connections like this in much declining use these days. Man, I'm trying to think of the last time I really saw these in broad use. It's probably been 10 years at least since I saw it, and that was a company that I worked for where they were paying us to replace all the coax because it was so old that if you would just bend it, you could start to see cracks in the rubber on the outside of that coax cable. So we replaced the whole thing, but that was the last time I really even remember seeing very much coax in use. At least in terms of making connections to individual PCs. We rarely see this anymore. You might still see it in place in some existing backbones. But even for backbones, it's starting to be broadly replaced by a better technology known as fiber optics. Now, fiber is an excellent connectivity method because it gives you extremely high speed and reliability, but it's very expensive. So that's why it's not used commonly, except for, again, for backbone, special use purposes, things like that. I don't think you're going to see fiber connected directly to PCs very often, however. Let's take a look at the kind of cable you'll have. Number one, you can have glass cable. It's actually going to use glass inside of a sheath of cable, and it's going to be wrapped around like with some protective coatings and things to protect that. But the disadvantage with glass is that, of course, as you would imagine, it's brittle. I mean, you can bend that cable somewhat without actually fracturing the glass inside. But if you do take it around too sharp of a bend or in a cable run where it's got to go around a corner that it might not like too much, it could crack and cause a connectivity problem. So there's the maintenance expense with that, and the installation expense is very high. You can splice them together, but it's a highly precision operation to splice those together, so that's not so good. But plastic is good as well. It will still give you a very high data throughput, but of course, it's going to be more flexible, so you can take it around corners and through tight spaces that you might not be able to take glass. The maximum distance for plastic, however, will not be as good as glass because obviously we're depending with fiber on light waves, and the light waves will travel further through glass without any imperfections than they will through plastic. And then we have two different kinds of mobile here, two different kinds of fiber. We have single mode fiber and multi-mode fiber. Let's go ahead and illustrate it this way. Here I'm just going to put a light bulb down here. Okay, that's supposed to be this where you screw it in. And of course, fiber doesn't actually work this way. What it does, this just represents a light. Kind of looks a little bit more like Raggedy Ann or, I don't know, the Bride of Chucky or something. But we have light waves going through a single mode fiber like this, okay? And so we have only one communication taking place over those light waves. With a multi-mode fiber, however, I can have multiple channels of communication taking place at once within that cable. So here's my first mode of communication going on, and then I might add another channel of communication taking place in there. And then we might have even yet another mode of communication taking place in a multi-mode fiber cable. But now you're most likely to see fiber in use in backbone networks, not for drop connections to individual PCs, like I said earlier. And the reason why backbones use fiber is because it's high speed, so you're going to get about 100 megabits per second up to 10 gigabits per second. And you can stretch this fiber cable for miles because it's using light waves, and as long as the quality of the glass or plastic is good, then you can shine a light through one end of the cable, and it'll go down to the other end of the cable for a long ways. And if you need to go a pretty good distance, you're more likely to use single mode fiber because since it only uses a single mode of communication here, then the light actually travels straight down the cable and it doesn't have to bounce off the walls, so to speak. Whereas multi-mode fiber bounces off the walls of this fiber, and as it does so, the signal weakens as it gets closer to the end. Single mode fiber is more likely to use lasers to transmit the data, and multi-mode fiber is more likely to use LEDs. And also, single mode fiber, if you can identify the actual cable itself as being single mode by the fact that the cable is yellow, and then the multi-mode fiber is going to be orange in color. And then off to the side here for your reference, if you want to know specifics about the distance, single mode fibers are rated for backbones to be able to go 3,000 meters in length or 9,840 feet. Multi-mode fiber is rated to go 2,000 meters for backbone and 6,560 feet. So then how do you connect these fiber optic cables to different items? Well, you can use the straight tip connector, the ST connector. This was developed by AT&T. It's probably the most widely used fiber optic connector, and it uses a BNC type of an attachment similar to what you might see with thin net Ethernet. They're not exactly the same, they just resemble one another. And then we also will have an SC. This is going to be a square connector type, and it uses a latching mechanism so that you can't pull out the cable unless you depress or unlock that latch that connects it. And we'll look at pictures of these here in a little while. Then we can also use a Lucent connector, because of the fact that it was named after the company that developed it, which was Lucent Technologies. Its common use is really more for telco environments, but it's been popular because it's a pretty small form factor. It kind of resembles an SC connector, only it's smaller. And then finally, you can use a mechanical transfer registered jack, an MTRJ. The registered jack part of this will fit into the same size of a socket as a normal RJ45 connector. Now, of course, it's not going to have wires in that connector. It's just the same size form factor, so you could plug it in there. Of course, inside of that socket would be fiber optic equipment instead of something like twisted pair cabling. And then for your reference, we have a photograph here where we have the different types. An SC connector. A neat way to remember this, because sometimes it's easy to confuse that with ST. SC for corners. Okay, this is a square connector with corners on it. So SC connector. This is the LC connector, which, as I mentioned earlier, kind of resembles the SC connector, except that it's smaller, of course. Here's an ST connector, a straight tip connector, and you can see here that it uses a twist-on kind of a style connector, very similar to what we have with BNC connectors. And then finally, here's the MTRJ, the mechanical transfer registered jack. This form factor would fit into, like I said, the same form factor as an RJ45 plug. All right, now let's go ahead and address twisted pair cabling. And how come my little mouse pointer isn't moving? Oh, great Scott. I'm using one of those Wacom drawing pads. That's what I use to draw, write all of this stuff up there and everything. And I use an electric pen that hovers over the surface of this drawing pad like that artists use. But I realized I had a yellow highlighter in my hand just now when I tried to move this thing. So now I got the right pen. Unfortunately, yellow highlighters don't move this cursor around for me. Anyway, let's get to twisted pair here. What kind of cable do we use with this? Well, all of these types are twisted pair of wire. Now, why do we need twisted pair instead of just, cable or wire that goes straight through the cable? Because if I have, let's just say, these two pair, or this one pair of wire, and I'm sending data signals down this one, okay, then it's going to overlap and sometimes interfere and touch on this other wire here, so that any signals that are also traveling on this wire can also overlap and interfere with this wire. So these two wires can interfere with one another and effectively prevent good data transmission. So what happens here then is we just take these wires, and instead of running them in parallel to one another, we put twists in the wire. This adds a little bit to the expense because the more you twist it, the shorter your cable lengths are going to be, so you're going to need to use more material to get your cable. But it has to be twisted in order to avoid things like crosstalk, which is what I just discussed right there, and also electromagnetic interference, and other types of electrical interference as well. There's several types of category cable. We call these category 3, category 5, and so forth, but we just shorten it to cat 3, for example. And with cat 3, you have a minimum of 2 twists per foot, but that doesn't give you very good reliability and data transmission. They can go as 3 or 4 twists per foot. So we rarely, if ever, see cat 3. You might see it for plain old telephone service installations, because most of these kind of cables can be used for network data transmission or telephone service. You may also see cat 5. This is going to be more common in the workplace especially. And with cat 5, you're going to see 3 to 4 twists per inch. So you see 3 to 4 inch twists per inch is substantially more than 3 or 4 per foot. And then you can go a step higher with that. This with cat 5, you can go 100 megabits per second, or conceivably a gigabit per second. However, it's not as reliable at a gigabit per second unless you went to cat 5e, which requires more thorough testing of that kind of a cable for it to be certified as cat 5e, and the wires inside of that cable are twisted and separated differently than the other two types. And then cat 6 as well is going to be a very high reliable cable in terms of getting high bandwidth up to a gigabit per second. And there's just a different orientation of those wires inside of the jacket than you will have with cat 5 or cat 5e. Now, most of the kind of cable you'll be working with is going to be what we call unshielded twisted pair. This means that there's going to be a thin insulator around each wire. Let me just show you a picture, in fact. Here we have each wire in a Cat5e cable, and notice that they're twisted around, like I mentioned earlier, but there's just the colored insulation around each one of these. This is not shielded, however. There's no metal braiding or anything like that. The shielded twisted pair, or STP type of cable, is going to be a little bit different, quite a lot different actually. What happens with that is it's kind of like taking that shielded twisted, or that unshielded twisted pair, all of these, and it's like putting them inside of a coax cable, because around to each pair of wires, like around this pair of wires, what you'll have is an insulator, okay, and then you'll also have shielding around these as well, something like that foil that you might see in coax cable, and that foil goes around all the twisted pairs. And then outside of that shielding, you'll have a shielding braid, and then after that, you'll have the external jacket that we see here. So you can see that it's quite shielded against a lot of interference, like electromagnetic interference and the like, that you might have if you run this alongside, fluorescent lights or ballast or something that has magnets in it or something like this, heavy machinery, equipment, that sort of thing. Now, as a side note, and this is not an A+ exam objective, but as a side note, with shielded twisted pair, only one end of that cable should be grounded to earth. That's just a requirement for this kind of shielding. If you accidentally ground both ends, which is quite a common mistake, then you could open yourself up to an electrical hazard because it creates a ground loop. And then for both coax as well as twisted pair, we have two different kinds of outer jackets that can be used, plenum rated or PVC. A PVC, if it catches fire, it emits noxious gases, and fire is dangerous enough as it is without inhaling noxious gases, so we might not want that in certain places, so depending on the safety requirements. Very often in plenums, which would be like an overhead area or something like this, then the PVC is not suitable, and this may even be according to building codes in a local area. So instead you would use plenum rated. Now plenum rated, instead of using a PVC material for the outer jacket, it will use Teflon instead, and it does not emit those noxious gases. Now, the kind of connectors we use for twisted pair wiring could be RJ11. That's what would be just a standard household phone jack. Most corporations will actually use RJ45s instead, but for households, you'll use RJ11, and I'm sure you know what that looks like, but it looks just like that. Here's a magnified view of it. It uses 4 wires in there, or 2 pairs, depending on however you want to say that. So there you have that. That's an RJ11 jack, and you'll need to know the difference between that and an RJ45 jack. An RJ45 jack is going to use 4 pairs or 8 individual wires instead, and that's going to, of course, be a lot wider. So there's your RJ45. By the way, RJ stands for registered jack. Now, this is not an A+ exam objective, but let me just quickly address how you might create your own cables if you wanted to. You'd buy a spool of cable from a local computer store or someplace like that, electronics store, and then you can go to use a crimper much like this one. This is one of the ones that I have, and you separate all of your cable like you saw how the twisted pair were all separated earlier, and once I untwist all of those, I arrange them in a specific order, and what we will do then is to crimp them in the crimper like this. Okay. Now, to get the jacket off of the outside of the cable, I can use this razor blade kind of an area on the other side of the crimper, and I can just depress that slightly and then twist it around the cable to remove that outer jacket. And then what you can see we do here is we arrange this in order. There's 2 main standards, but this is one of the more common ones. And you arrange the color of the cable in this order. You'd be orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Just so you know, by the way, this cable here, this wire here, looks like it's orange-white, but that's just a reflection of the adjacent orange cable. It's actually a green-white cable, or wire. So anyway, you've stripped off the outer jacket, and then you've arranged these in the correct order, and then you slip it inside of this RJ45 jack. And then here's a magnified side view of that jack, and notice that we have these taps on each one of these plungers that appear inside of that jack. What happens is you put this then into that crimper, and when you depress it down, it has a mating that appears right here above each one of these plungers that pushes it down into the cable. And then here's another view of it where you can see that these plungers have gone in and made contact with the inside of that cable. I once was a copy editor for another author who wrote a book on Network Plus, and this woman said that you had to strip the insulator off each one of these little wires. That was the most ridiculous thing I ever heard of. You don't have to do that. These taps will go right into it and make good contact with these. And then what happens is when you plug this into an RJ45 jack, the signals traveling up and down this wire, because of the conductivity of this plunger, will go up through this plunger, and then the top of the plunger will be in contact with a wire inside of that actual jack, and that's where the data transmission happens. Now then, depending upon the type of cable you're working with, you might use either an RJ45, and that's by far the most common, or an IDC UDC connector. IDC stands for IBM data connector, which is also synonymous with a universal data connector. The RJ45 type of a jack is what you use to connect, if I can move my pen around here, to UTP, unshielded twisted pair cable. IDC or UDC types of connectors are what you use to connect shielded twisted pair cable. If you want to see a picture of IDC, UDC, let's go ahead and take a look. And here's a picture of one right here. And this is where your ground comes off, by the way. We mentioned grounding a little bit earlier. But this is kind of an interesting cable because most cables are either distinctly male or they're distinctly female, usually for the jack side of the connection. I call this the Michael Jackson of cables because it's neither distinctly male nor distinctly female. What happens with this is you can use a hermaphroditic connector and you just turn one side around. They both are exactly the same way, and you just flip one side up and the other side down. It's kind of like a Lego piece that sticks in together, and you connect them that way. And then as we conclude this section here, let's talk also about duplexing. Let's really start with the half one. The half would be kind of like a walkie-talkie conversation. If I'm holding the button down and talking, you can't say anything that I can hear. You have to wait for me to finish and to release the button on that walkie-talkie. It's like my son. For Christmas a couple of years ago, I got him the Incredible Hulk walkie-talkies, and he kept trying to listen to me while he was holding the button down. Well, that just doesn't work. You got to let go of the button before I get to talk. Well, that's the way it is with half duplexing as well. Most older Ethernet network equipment was half duplexed. Now, most current equipment that you buy is going to be capable of full duplex, which means that it can operate twice as fast because it's able to send and receive data to both parties simultaneously. It's more like a telephone conversation than a walkie-talkie conversation. Now then, to conclude all of this, I also want to just point you to a document that will help you with some of these other cable styles that have a lot of different types, such as the different RG types and the different category types here as well. This is just going to be a document that you can use for study purposes. Like a lot of other data and stuff like that for A+, I don't think you're going to need to memorize this verbatim, but you should be able to look at it and to pretty well tell whether or not it's going to be true or false. So for example, if you see something that would claim that RG6 is good for 1,000 base T Ethernet connections, well, you know that won't be true because look, that's going to be for Cat. Oops, if I can use my mouse, Cat 5e or Cat 6, but that wouldn't be true here because we use that for satellite TV. So just be able to identify whether something looks true or false. And then I've got some additional notes down here at the bottom for you as well. In this nugget, we talked about networking, and this was part 2 where we started off just by talking about other cable media that I think I made clear you're probably not going to really use in the real world, but we then moved on into some other cable media. One of the older standards there would be coax cable. And we talked about some of the different types that you might see and their usages, and we also talked about fiber optic cable. Now this is something that's in use currently today at very high speed, and it can go for a great distance without losing any signal quality, so it's extremely good, but like we said earlier, it's pretty expensive too. And then twisted pair is probably the kind that we'll see the most commonly in any kind of a local area network. It's not too expensive, and it's very flexible and easy to install. And it gives you good connection speed at current standards, up to 1 gigabit per second. Well, I hope this has been informative for you, and I'd like to thank you for viewing.